Hello everyone, welcome back. In this video, we're going to learn about two more topics related to functions, function stubs and function prototypes. Let's head over to the notes. Our homework task for today's notes is to make a copy of GPA computation fun.cpp, call that copy prototype fun.cpp, then go ahead and open up prototype fun.cpp in gedit. In prototypefun.cpp, we're going to convert our GPA computation fun to make use of something called function prototypes. So let's start working on the warm-up task. All right, let's start our discussion with function stubs, which will be a short discussion because function stubs are fairly straightforward. You can define a function without putting any lines of code in the body. This can be useful when you want to test your program one function at a time, or you want to organize your program without actually writing the functions. You can think about a function stub as being a placeholder for a function body that needs to be filled in later. For example, here's a stub for a function called find quadratic root. So it has a comment block before it, it has a function header, and it has a body. Now, in the body of this find quadratic root function, there's just simply a cout statement with a to-do or a todo statement that says implement find quadratic root. To-do or todo is usually used to represent something that needs to be done, something to do. So often you'll see todo in IDEs, integrated development environments, and in code, for example, and that's what it means. And then this function returns a double value. So in order to compile, it has to return a double value. So it's always returning negative 1.0, which is just a dummy value. There's no actual implementation of the quadratic equation in order to find the roots of a quadratic function using this formula here. That's to be implemented later. But this function is stubbed out, hence function stubs, so that at least the architecture of the program is getting in place, and then somebody else on a software engineering team at a later point may come back and fill in the actual body of this function and do the testing at a later time. So function stubs are really useful in order to maybe get an initial design of your program. For some of the programming assignments, I'll state you have to have these exact functions. Other programming assignments, I'll just say go ahead and come up with your own functional design. In either of those two cases, take advantage of function stubs, because in the former case, you can go ahead and just copy and paste the headers from the programming assignment specs into your code and then just stub out the body so that you don't miss any functions that are required for the assignment. In the latter case, you'll probably want to draw a structure chart to apply top-down design and come up with some kind of good modular approach. That modular approach, you can stub it out using function stubs just to get a sense of how will all of these pieces fit together. Are these functions loosely coupled? Are they highly cohesive? Do I have a good design? And if you have a good design before you start writing code, you'll probably save time in the long run when you're actually implementing the function bodies for those functions. All right, so now on to kind of the main event of this lesson, which is function prototypes. Function prototypes tell the compiler what functions are defined. We know from previous lessons that when the compiler compiles our code, it has to first see the function definition before it sees a call to that function. Otherwise, the compiler doesn't know all of the requirements that it needs to know about a function in order to compile code that calls it. Well, function prototypes get around this requirement of having to have the definition above any function calls. A function prototype is simply the function header with no body. In fact, at the end of the function header, instead of curly braces, you'll just put a semicolon. If we have a function prototype for every single function in our program, and we put all of those function prototypes together at the top of our file above main, then by the time the compiler gets to any actual function body, whether that be main or another function, it will have seen all of the required information about how to call a function beforehand via a function prototype. And no function prototype for main is needed. Okay, so let's take a look at an example function prototype. Here we have a function prototype for the display GPA function that we wrote a few videos ago. So we have the return type, the name of the function, and then we have the parameter list. Now, this is all the compiler needs to know about a function in order to compile any code that may call it. So if we have a prototype for display GPA above main such that when a function call is encountered for display GPA in main, the compiler is already aware of it. That means we can put the actual definition for display GPA somewhere else in the code, perhaps after main, instead of requiring it goes before it, because we'll require that the much shorter function prototype goes before main. One thing to note before we take our GPA computation fun code and convert it to use prototypes is, while I said that you can simply take the header of a function prototype and put a semicolon, the header of a function definition and put a semicolon on the end in order to make a function prototype, your function prototype can be even simpler than that. The compiler doesn't care about the names of your parameters. It only cares about the data types of those parameters. So simply having void display GPA double semicolon would also be a valid prototype. In fact, in many cases for your prototypes, you don't want to list the name of your parameters because those might change, and then you might have to maintain the names in two spots. So I'll usually go with this approach where we just list out the data types of our parameters. Okay. So the general format of a .cpp file, now that we know about prototypes, is we'll still have our file level comment block at the top, preprocessor directives like our pound includes, our using namespaces like using namespace standard, our constant global variable decorations, and then our function prototypes. Then we have our main definition, and then in any order, we have our other function definitions. Before, the order of these function definitions depended on the order at which they were called, but with function prototypes, we don't have that restriction anymore. All right, let's head over to our prototype fun.cpp and let's convert this code to make use of prototypes. Right now, all of our functions are defined above main. Let's go ahead and move them below main, or in other words, move main above all of our functions. So now our code won't compile. Just to recap why our code won't compile is because the compiler compiles our code from top to bottom, and when it encounters, say on line number 10, a call to the function getGradePoint, it doesn't know anything about getGradePoint. It doesn't know if this call actually adheres to the definition of getGradePoint. So that's where our function prototypes come in. We can go ahead and add a prototype for getGradePoint above main, and then the compiler will be okay with us calling getGradePoint here, even though it hasn't seen the definition for getGradePoint. That's somewhere down here. So let's copy the header for getGradePoint. And paste it above main. I like to delete the name of the parameter just to make our prototype shorter and easier to maintain. Now, when the compiler compiles from top to bottom, it's going to find the prototype for getGradePoint, know everything it needs to know about getGradePoint, such that on line number 12, when it sees a call to getGradePoint, it can match the values being passed in as arguments to the data types of the parameters and the return value of the same type as the specified return value of the prototype. So let's do this for the rest of our functions. The order at which we put our prototypes above main does not matter. You may decide to put them in the same order at which you define the functions below main. You may put them maybe in alphabetical order. You may group them based on how they're executed in the program. That's kind of up to you as the programmer. All right, let's try and compile this again. And now it compiles. Let's run it. And everything looks good. So to wrap up our discussion of prototypes, I want to present to you this 5-step sequence for how to write our own functions. So first, you'll need a function prototype. Put it above main. And then you'll have your function header and your function body somewhere after main. Then in your code, anywhere, you can call your function as many times as you would like. And then once you're done calling your function, then you're ready to run your code.